Hello, everybody. In this recorded session, we would be discussing, or I would be showing you some of the little bit more advanced ER diagrams or ER questions compared to the previous recorded one session. So let's get into it. That's the first question. A company has a number of employees, or you know what, I'll be quiet for a minute. I'll let you go ahead and read this. Or you can pause the video and read it. So basically, when we read it, we can right away can make out it's one entity here. The question is pretty straightforward in that. And then these are its attributes right here. And then project is the second one attribute, and those are its attributes. So let's draw up to this level. I'm going to Lucid Chart. The first one would be employee ID. Let's say first name, last name. Remove that key. Oops. Remove that key. That one. This one is primary key. The other one is project ID, project name. Then we can say start date. Okay, and of course that's the primary key. Okay, let's define the relationship between these two entities. So to define these entities, we should rely on the business rules. So let's see what the business rules are. Each employee may be assigned to one or more projects. So one or more projects. So employee may be assigned to one or more projects. So one or more, many. Let's figure out the minimum one. Or may not be assigned to a project. So that's a key point, may not be assigned. So that means that an employee at some time might not be assigned to any project, which means optional. Now let's see a project relationship with employee. A project must have at least one employee assigned, which tells us the minimum is one, not optional, and may have any number of employees assigned. May have any number, which says maximum is many. So this will become maximum many, minimum one. So right now we have many to many relationship between these two projects. Let's go back to the questions language, and we know right away that we need an associative entity here. An employee billing rate may vary by project. So what's that telling me is that the billing rate of an employee is different per project, and the company wishes to record the billing rate. Do the attributes name and description follow the guidelines? Yes. Do you have any associative entities? Yes, we do. So what would be the associative entity? As this is very helpful question with good language. Right here, this billing rate, we can use that as an associative entity, because the whole purpose of billing rate is to capture or record each individual interaction between employee and project, and that's what the purpose of associative entity is here. Perfect. Oh, that's the other side. So that would be the answer to this question. Do we have a billing rate? Okay. And what will we do here? We will say employee ID, of course, will bring here. Project ID will bring here. And then, of course, we will have a attribute called billing rate, which this billing rate would be for a particular employee, Nitin Walia, when he's working on project P01. And Nitin Walia might have a different rate for project P03. And these both are primary key, comma, foreign key. Same with primary key, comma, foreign key. Same thing here. Okay. So that's the first question. Let's go to the next one. Okay, I would let you read the question. It's about chemists, so go ahead and read the question. You can pause the video and read the question. Okay, so in this question, let's read it. A laboratory has several chemists. Attributes of chemist are this, which tells me chemist is one attribute. And then they are working on projects, and there are attributes of projects, so that's a second attribute entity. And then they are using equipment, which has attributes, so that's your third entity. And then the organization wishes to record a sign date and for each particular date when equipment was assigned to a chemist working on a project. So let's start putting the ER diagram together. And I would suggest you to do this for every question you do related to ER diagram. That is, first put all the entities you think are part of that question, that scenario, on the canvas, and then go back to the question and start assigning or the relationship among them. So that should be your starting point. So first, just put all the entities on the canvas with their attributes. So let's start with the first one, chemist. Project and equipment. So chemist ID, which is the primary key. I'm just going to write the first one. You can look at the solution on the PowerPoint for a more detailed attributes. Okay, so that's the primary key here. So let's see what's the relationship between chemist and project is. A laboratory has several chemists who work on one or more projects. So chemists who work on one or more project. So one or more projects, and as it says, chemists are working on it. So the other one is also many. And some project might not have anybody assigned. So minimum, let's keep that optional. Okay. Chemists may also use certain kinds of equipment on each project. Let's say if we get more detail, these are the attributes of equipment. Assign date, that's a date when a given equipment was assigned to a particular chemist working on a project. Chemist must be assigned to at least one project and one equipment item, and given equipment item need not to be assigned, and a given project need not to be assigned either a chemist or an equipment. Okay, so a lot of things happening here. Okay, so how will I interpret what I read? So I'm gonna bring the equipment here. So the question says, and I'm reading it on my other screen, that a chemist must be assigned to at least one project and one equipment item. So we know that a chemist has at least one equipment, so that's the minimum, and given equipment need not be assigned, and a given project must be assigned to a. Okay, so this is what I'm like. This question is a little bit complex. So before we get into the both maximum and minimum cardinality, it looks like that all the three entities are connected to each other, because that's what the question language is telling us. And furthermore, each at the maximum, I'm not talking about the minimum, but at the maximum, each of those entities have many to many relationship with each other. A project can have one equipment assigned or many equipment. Equipment can be assigned to one project or many projects. Same way, a chemist at the minimum get one equipment, maximum many, and same way equipment can be assigned to many chemists or one chemist who furthermore are assigned to a project. And the question also says that equipment might be assigned to a chemist and or a project. So it's kind of a confusing. So this is basically a very good example of a ternary relationship where there are three entities and they all have relationship with each other, direct and indirect. So in the ternary, and that too many to many. So in the ternary relationship, just like in the past where we have been introducing an entity in between these two, in this relationship ternary where all three are connected to each other, we will again introduce one entity here, or you can do one here or one here, or since all the three are related to each other, we can do a much more efficient thing. We can just introduce one entity, child entity, which connects all these three together. All these three together. So far we have done all the questions where this became a child of these two parents, and these were two entities, urinary, and this has become the ternary relationship. Three entities are parent of one associative entity. And since we are doing that, let me say this was the primary key, and this could be assigned because we are assigning equipment to a chemist who are part of the project. So that's why we're going to name it equipment. And the first rule of when we have this associative entity is bring the primary keys of the parent, so which is foreign key, project ID, foreign key, serial number, which is foreign key. And in the previous examples we have done so far, we'll make those both foreign key and primary key. So here I'm going to do something different. You do have the option to make this first three IDs, chemist ID, project ID, serial number, as foreign key, and we can combine these three together as a composite and make all three together as the primary key, which we have been doing so far. But there's another approach, and again, whether you take this approach or the other one which I'm about to talk about, they both are logically correct. And what's the other approach? Since three entities working as primary key will make it very difficult, or will make the queries much more cumbersome, because we always need to refer to the primary key when we are pulling data from that particular table. And since now this table has three primary keys, if we make them primary key and foreign key, it will become the query very long. So what we can do in such cases is we ourselves come up with a new primary key, which we generate for just for this entity. So you just make a new attribute. This one is assignment number, which would be unique to that combination of that chemist, project, and serial number. And we came up with this new primary key called assignment number, and we will make that as a primary key. Now your question might be, can we do the same thing here also? Can I come up with a new field here called billing number and call that as primary key and not use these two as primary key? Yes, you absolutely can do that. But if you look at the other side of this double-edged sword, here we were trying to not to use three attributes together as primary key. That's why we came up with the fourth one to save us time and reduce the sort of the queries burden. But on the other hand, we just had these two attributes as a primary key, and now what we have done is, by introducing this one ourselves, in this case we added one more attribute to the table, one more field to this table, one more thing which we have to worry about, one more field which we have to write about in the data dictionary and maintain for the data integrity. So you have to look at the gain and loss. Here the burden of three attributes as primary key, the burden is much more than just introducing a new one ourselves. But on the other hand, maintaining just these two as foreign key and primary key, the burden is not that much as compared to ourselves coming up with a new number. So that's sort of the give and take you have to see. Two, we can digest, sort of, it's manageable. Three becomes difficult, so it's better to introduce a new attribute ourselves. So that's sort of this solution to this question. Then our next question, which is a little bit different. In this question, you are not getting any business case or some language written like on the other two questions. What's happening here is that you went to some business and they gave you a printout of this report, which they might be creating by hand, maybe on an Excel file or something like that. So they said, this is the report which we are creating, with our current system, which is not very good, can you make a database which whose output is this report? So our goal is to create a database which produces this report. And how do we do that? Before we can create a report, we have to have tables to store data. Before we can make tables, we have to design an entity relationship diagram. So for entity relationship diagram, our starting point is this report. And so we are doing a reverse engineering in this case. So let's start with our reverse engineering. This part, header of the report. So not part of database. When you print a page, this is sort of the header which comes on its own automatically. Name. Whose name? The student's name, student address, student's major. Our first entity. Course ID, course title. Looks like that is our second entity. Who's teaching that course? Instructor. Instructor location. That's a third entity. Then grade. Grade is assigned to a student for a course by instructor. So where should the grade go in? Let's draw the ER diagram, figure it out at that time. But at least we know this is one entity, second and third. And what would be the student attributes? The attributes would be ID. So student ID would be your primary key. Name, which we will break into first name, last name. Address, which will be broken into address, state, city, and major. So those would be your ID, first name, last name, address, major, so on. Then you have your course, course ID, and title. Course ID and title. Third one is instructor name and instructor location. So instructor first name, last name, and location. Can we make first name as primary key? Nope. Two instructor can have the same first name. Can we make the last name as primary key? No. Two instructor can have same last name. Maybe their location or office number. It might work, but what if two instructor are sharing their office? So in this case, there's no instructor ID. And that's where the MIS person or the business analyst or IT analyst will go, will themselves introduce another field here called instructor ID, which is generally done to satisfy the rules of database. So even if the users don't have instructor ID, we'll tell them let's introduce it. If they don't want to introduce it, we will introduce it for our internal database purpose. A student can take more than one course. At the minimum, we have done this many times. Minimum none. A course can have many students, and the minimum again none. A course is taught by one instructor, and at the minimum I'll say maybe a course has not been taught by anybody. An instructor can teach many course or no course. Okay, so what's happening here now is this has many to many relationship. We have to bring another one, and so basically now you can see what are we doing with this associative entities. What's the purpose of that? I'm hoping that it started making to sense to you. That, for example, Nitin Walia student might be taking many courses, MBA 545, 513, 547, and so on. Same way, MBA 45 might have many students, Nitin Walia, Mike, Ahmed, Amit, you name it. So what does this associative entity does? It records each, I don't want to say individual, each unique interaction of course and student. So for example, this is recording each instance of Nitin Walia. I'm just writing it as a matter of to show you, and MBA 545 record. So because each of those Nitin Walia MBA 45 results in a grade coming, because that has a unique record grade, which is what, where this will go in our associative entity. So I'm hoping now you are starting to see the need of gradebook, which is recording each individual interaction between these two parents, like here, here, or here. So that's the purpose of associative entity. Last question of the day of this lecture, which I will not do, I will show you. This is a big question. I use this question, I developed this question for one of my exams. Not me taking that exam, but the one I gave to my students. So this is a fairly big question, and that's its solution. The only thing I have not covered in this class, because this class we are covering the sort of the basic and foundation. In one of my advanced courses, I teach this thing as well. What is happening here? This is called supertype and subtype relationship, and these are part of enhanced entity relationship diagram. So they are called EERD, enhanced entity relationship diagram. They are not that commonly used, so you're not missing on much. But the rest of the thing is what we have done. If you want to read, please go ahead, read on supertype subtype relationship. It's not that commonly used in ER diagrams, but I thought I'll show you a question with that kind of example as well. So I will recommend that you read this question and at least go through the solution if you don't want to do it yourself, and see a little bit of complex question and what the final solution of all these business rules are.